function. So when you call it from the person class, it's going to say person. When you call it from the employee class, it's going to say employee, so on. So what happens when we don't override it here, and then we call it in the tutor class? Tutor T T.overview. So anyone can predict what happens when I do this? Yes.
It's tutor puts on and goes so.
So what will be printed out when I call this?
Or tutor.
Yeah, it's ambiguous, right? So the same problem with the name. You have, even though this one doesn't inherit, it doesn't override. Who are you? Doesn't mean that it doesn't have a who are you function to call. It would just simply have the function from person copied over to student. So if I try to run this, it's going to say ambiguous. Oof, again, it's problem with this name. Right, so remember who are you found in multiple classes, which is exactly the same as the problem we had with name. I'm not sure if we can do this. T dot employee. I think we can do it. Just run it. Okay, so we can run it. So if we give it the fully qualified name, then the compiler will know where you called it from. So when you treat T tutor as an employee and you ask who are you, it's going to say I'm an employee. And then if you refer to it as a student, right? So what have we printed out here? Person, right? Because it just simply inherits the who are you from person class. So let's just for completeness, I'm going to implement it here. Right. So now it will say student. This is just C-line being stupid. Yeah, so this is still a fully qualified name, and it knows exactly which who are you function to be called. And this one. Right. Now, can I do this? We know that student inherits person, employee inherits person, and tutor inherits employee and student. So, can I do this? Guesses?
Yes.
Yeah. Not a cat. So this is again the same problem, but it is even more complicated than copying stuff from this scope to the other scope. What happens is when you inherit employees from person and student from person, not only the variable names, the variables and the functions in here are copied over, but also the entire class is copied over as well. So inside the scope there is a sort of placeholder. Person inside employee scope, and then person inside student scope as well. Right. So when we inherit tutor from these classes, we end up with two scopes person. And when you say person, it doesn't know which person. Right, so this is insane, but yeah, just be careful. Did you see something like this in the exam? So you can only refer to the fully qualified name using like this, using the name of the immediate base classes. So T is a tutor, it can refer to employee or student, but it cannot refer to tutor. It can if you give it stuff like this, employee, and then scope to person, and then scope who are you. Nope, sorry, you can't. You can't. So fully qualified scope like this is reserved to the immediate base classes only, these two classes. Tutor cannot access the scope of the grandparent. So that answers this question. Well, what if the virtual method is overwritten in one intermediate base class but not the other? Well, the fact that it's not overwritten in the other class doesn't mean that that other class doesn't have a function. It just simply has the same function. So this is basically a tricky question. Right. So same thing that you've seen in my code, except that you can avoid the problem by using the keyword virtual. So all of these problems will go away if we refer to these classes as virtual base. Well, the problem with the name will go away, but the problem with who are you is probably still there. So what happens is, even though you declare your function, your base class as virtual, what you have is still two copies of the same function, and at runtime, it still doesn't know which one you refer to, because it inherits both. But if I remove this from the student class and I remove this from the employee class, there is no ambiguity anymore, because there is only one who are you function. So it is resolved, the name resolved at runtime from the class tutor to class employee or class student, and then from these two classes up the tree to the class person where it finds this function, and it will call this function. So using virtual isn't guaranteed to solve all of the problem. If you have two copies of the same function in two base classes, you still have the problem regardless of whether you have the virtual keyword or not. This only solves the problem of the diamond inheritance. So by declaring virtual here, you say all my grandchildren will inherit my function and data member. Yes?
If those who are you functions were put back in
To these classes?
yeah, and those are still covered virtual, in the tutor, could you call who are you the employee?
Yeah, sure.
Scope?
You can do that.
And we'll go back.
Yeah, but then the virtual keyword doesn't solve this problem. So the virtual keyword is there to fix the diamond inheritance problem only, not to fix the multiple inheritance. Remember that. It's not to solve the multiple inheritance problem. It is to solve this problem, this particular problem, only this problem. Not this problem. All right? Okay. So difficult to understand? Yeah. If you have any questions, just ask. All right. So other than abstract classes, we have another concept, and this is not a concept of C++. This is a concept of object-oriented programming. And we don't really have an interface notion per se in C++. We do have interface in Java, in C#, and in other high-level languages, but we don't have it in C++. An interface in C++ is simply an abstract class with virtual function only, pure virtual functions only. So recall that an abstract class needs only one pure virtual function. It can have 10 functions, and 9 of them are not pure. One being pure is enough to make it an abstract class. But if all 10 of those functions are pure, then it is an interface. Right? And another thing is, it shouldn't have any data member. If it does, it should be final. So the concept of interface is that it is stateless. Stateless. Meaning that it is immutable, it's unchangeable. So when you have an instance of a class A, and then you can change something from it, a dot name equal, or a dot set name something, you can change a property of that. It is mutable, and it has a state. So it can have a state of having a name A. When you change name A to B, then the state of this instance changes. But an interface is stateless, so you cannot change anything. So in general, if you want to declare an interface, you shouldn't have any data member, because it could be confusing. But if you must have data member, then it must be final, like this. So class I, person, I being interface. You can have full, virtual full, pure, virtual, void full, and then virtual in bar is also pure, and all the other functions are pure. And then you can have your data member as well. Int, let's say class name. Now, but you don't want this to be changeable. You want it to be set at compiler time. So you declare this one final. So if it is final, you can change it, and once you create an instance of something that sort of implement this I person, then the class name is person. And it is still considered stateless. So again, in C++, there is no there is no actual concept of interface. It is a concept of object-oriented programming, but it is the same in any language. All the functions inside an interface should be pure virtual, and if it must have data members, then all those data members should be final. In Java, if you declare a data member inside an interface, then it is by default final. You don't even need to declare it final. It will be made final. And an interface usually contains functions that declare the behavior of the class, or what it can do. So you usually see interface with something above. Right? It declares a set of behaviors that should be implemented by the derived classes. So a shape is something that can draw on the screen, can draw on a printer. It's drawable. Or we can implement a bird to be flyable or edible, right? Or anything else. So this flyable interface will probably declare the fly function, edible will probably declare an eat function, and so on. But this is just convention. You don't have to make it something able. As long as you don't have any concrete function, or you don't have any non-final member data, then data member, then that's fine. But in C++, there is really no difference between an interface and an abstract class in terms of how you declare them and how you inherit them as well. So when we get to Java, you don't extend an interface, you inherit, you implement an interface, and you don't implement an abstract class, you extend it. But in C++, you inherit both using this notation. Yeah, so again, interfaces shouldn't have any data members, but it could. But in case it does have data members, all of them should be final. Otherwise, this is not qualified to be an interface. can call it an interface, but it is not. Too fast. So all of these are inheritance paradigms. You can remember them. I'm not sure if they will turn up in the exam, but if you understand the concept of inheritance, then you shouldn't have any problem. You know, if you're asked any of these, explain what happens here. So this is single inheritance. You have class B inherits from A. Multiple inheritance is C inherits from B, B inherits from A. This is probably not the actual term. We skip it. Multiple inheritance is this. Class A inherits from both B and C. And hybrid, I'm not even sure what that means. This is probably not really that important. Alright, so let's summarize. In C++, there is no there's no inherent concept of abstract classes and interfaces. An abstract class is simply one or more pure virtual functions. An interface is simply all pure virtual. Shouldn't have data member if it must have, then they must be final or constant or constant. The virtual keyword, so virtual inheritance is there to specifically solve the diamond problem, not the multiple inheritance problem. And the scope operator is to solve multiple inheritance. So to solve these two problems, virtual is to solve diamond, scope is to solve multiple inheritance. And in general, to try your best to avoid this problem. I guess we can go into the next lecture a little bit. Now, before we move on, is there any problem? Anything that you don't understand? Yes?
The interfaces, if all those things were pure virtual, then they have to be defined classes. You're going to have to do that work anyway. Why go to the trouble of creating an interface?
Sorry, what's the question again? Don't quite get.
Sorry. With the interfaces,
yeah.
You have to provide the functionality of those methods in the interface, right?
you don't have to provide any functionality. You need to provide the name, the declaration. But if you do, if you do provide any implementation for any of those functions, then that is not an interface anymore. That is just an abstract class.
Yeah. But you have to provide the functionality to the
Well, that is not functionality. That's declaration. And yeah. So the name of the function and the types of the arguments, but not the body of the functions. All right. Anything else? Any other question? Try one more. No, definitely not. Yeah, so again, remember when you have a diamond problem, then remember that a derived class can only use the scope operator to call the immediate base class, not the grandparent or great grandparent class.
How do you access the grandparent classes then?
I'm not sure, to be honest. I think it is possible, but you probably will have to do some trick. So obviously you can't call it like this. This is only applicable to the immediate base class. I think if you want, you must call the grandparent, then you could probably do something like this. If you want the behavior of who are you to be the same as a person, you would still override it, but instead of providing its own behavior, in here you will call employee, student, person, who are you? So now I guess we can do it. We can call who are you, and we get this one to print out person. Yeah, so this is how you do it. You basically fake overriding a class, a function. So you override it, but you don't really override it at all. You simply access the upper class implementation. Yeah. So when it is inside a class, then you can do this. But because this is a class itself accessing its grandparent, but when we call t dot something here, it is actually the main function that does that. So this is one way to avoid a problem. And if this function is not void but in, for example, then you simply return it. Or even if it is void, you can still return it. Yeah, but try your best to not get into the problem of multiple inheritance, and definitely not the problem of diamond, because you get yourself in so much trouble. Even with this very simple example, we already have a lot of problems. So if you design your own class, never do this. What assignments are you at? Is it part 2? 1 part 2 or 2 part 1?
2 part 1.
2 part 1. Is it about implementing some sort of inheritance? Yeah, a lot of people try to avoid they still have this problem, but they sort of avoid it by having all of these in here. Sorry, they don't have the diamond problem. Diamond problem is kind of unsolvable. But when you have this multiple inheritance, you sort of put all of these in one class. So this is really bad because the person doesn't really have a salary or a grade. They should exclusively belong to these derived classes. That's just an advice to do your assignment. I guess we'll do the exception tomorrow. And we're done.